you bury the frame of it. Like, so you take all the wood off of it, but then the plastic part is like a really nice pond liner, actually. So, if we're looking at buying a new hot tub, let's check out this situation. So it says, draw a diagram or write an equation to represent each scenario below, solve the equation, and then explain whether the solution makes sense. Oh, man.
No, it actually makes all sense.
So Ernie's going to install a hot tub in his backyard, and he plans to add a 3-foot wide deck on 2 adjacent sides of the hot tub. So if Ernie's backyard, which is also square, has 169 square feet of space, what is the largest hot tub he would be able to have? Now, even if you look at this problem and you're like, oh, well, I know how to do that in my head, let's set up a quadratic model to support so that when we get to situations that are too complicated, then we can actually use a quadratic model to solve those complicated situations.
X plus 3 squared.
Yeah, but you guys, it wouldn't be fair because there's only 3 of you. And if one of you didn't turn it in, then you'd drop all the way down to a 66%, so that wouldn't really... it wouldn't really be good for a class of 3 to compete against classes of...
But we're a class of 3 that only has to turn in our homework once every month.
Yeah, but then I'd have to collect your homework every other day.
Oh, no, let's not do that. I can't do homework that quickly.
That's the other reason why I felt like you guys would be fine to just sit out. Now, whatever prize reward thing I do for them, I may just lump you guys into it because you're awesome. So, the hot tub is square. Do we know the size of the hot tub?
Yes, kind of.
You just said nope and then yes.
We know its relative size.
Nope, X.
We know it's a square.
It's
So,
X squared.
It is x squared. Okay. Hot tub by hot tub, it is x squared.
And then you add 3 to both sides of the x's.
And then we're going to add 3 to both sides of the x's, you said. This is starting to look like a model that we've done before.
Oh my god.
Oh, it's an area! Wow!
Wow! So it's X squared plus 6X plus 9 equals 100. Yeah.
And then you take the square root of 69. Oh. How many?
It's what?
It's 13.
What is?
It's
Okay.
the answer is 10, but how?
The biggest hot tub you can work is 10 by 10.
Yeah, but
How can you work the work here to support?
you subtract 9 from both sides, and then it's kind of obvious.
Can't you do an inequality or something like that?
Wait a minute. When you subtract 9 from both sides, then it's kind of obvious. So when I write down x squared plus 6x equals 160, this is kind of obvious?
Yeah.
Yeah.
Do tell. Say more words. Help me understand better.
Well, okay. So you have a 6, and you have another number that's not work. And the other number is 160. So
It's 160, not 160. Okay, sorry. I had to say that.
Well, I'm speaking Spanish translated into English.
Okay.
This does not seem easy to deal with.
It wouldn't be if it wasn't such a nice number. But it's a nice number.
Now, wait a minute. Jake was sitting there saying it's 13, and I don't see a 13 anywhere up here.
Yeah. Wait, square root of 169 is 13? Huh? That...
But you didn't tell me to square root 169. You told me to subtract 9.
Wait, who told? Well, yeah, because you put that equation up there that confused me. But the answer is 10 both ways.
Well, wait. What equation should I have put up there then?
X plus 3, the quantity of x plus 3 squared equals 169. And then you square root both sides, and then it's simple. But both of them equate to the same thing.
Oh, so if this side is just like something squared equals something, that's a lot easier to work with than if we actually have a trinomial.
Yeah.
Yeah. But also, the trinomial is simple.
Well, if the trinomial factors back to a perfect square.
Yeah.
Okay. Okay, fine. I believe you guys now that 10 is what works there. Or the largest number we could use, right? It's a pretty big hot tub, so you'd probably go slightly smaller than that.
10-foot by 10-foot hot tub. That's like a pool. It's just warm.
I know, I feel like that's kind of big. I mean, most are probably like 7 by 7 or 8 by 8, so that you could potentially lay down in it. But alright, Gabby is creating a decorative rock garden now.
Oh, wow.
That's going to cover 12 square feet in her backyard, including the frame. Now, guys, I warn you now, there are trapdoors here. She plans to build a 6-inch wide wooden frame around the rock garden to keep the rocks in place. I already see one trapdoor. I see 2 trapdoors.
Well, we don't know if the backyard is perfect square.
Doesn't matter. Her rock garden will cover 12 square feet. That is what we know.
I figured it out.
So, you're right. We don't know if it's going to be a square or not, but we do know its area is going to be 12 square feet. Oh, if the framed rock garden is square. Oh, well, there we go.
Oh, well then it's x plus 12 squared. Equals. We don't have that number either.
I got it.
Wait. I don't think.
Anyone want to identify a trapdoor here?
Well, the 6-inch wide wood, you have to double it.
Yeah, but it's not.
And then you subtract.
No, wait, why? Explain.
Because it's on both sides.
It's on all 4 sides.
Well, on all 4 sides.
So that 6 inches is on both sides. So a trapdoor that math likes to give you is when they give you a dimension, and that's not actually the dimension we want to use. So you're saying go ahead and call this x by x. But then it's plus 6 on both sides. So if we actually shift our square over, it'd be adding 12, right? If we kind of make it square corners line up.
Yeah.
So I don't like that drawing, but you guys know what I mean. If we kind of drag the square over, 6 and 6 is 12.
Or you can think of it as 6 plus x plus 6.
And then simplify, right? So, alright, x plus 6 squared.
Equals 12, because we know this is 12 square foot over backyard.
Wait, isn't it x plus 12 square?
Yeah. You're right, Jake.
I'm actually right about
That's how I feel when I'm. And then we just square root both sides and then subtract off 12.
Alright, go ahead.
But that's not going to be right.
Why?
Because the square root of 12 is not more than 12. And you can't have a negative area. That just don't make sense. So, also, I don't have a calculator, so I don't feel like doing it. Anyone got a calculator?
I'll get it out.
Calculator's still not going to help you here. You're in a trap. I mean, you can get a calculator, but you're down in a pit.
Okay, then.
You got to climb out of the trap first. You guys fell in. I'm sorry. I warned you. There were multiple traps, and you're just like, ducky, ducky. Okay.
Well, you didn't say what they were.
I know. That's not my job. I was just like, hey, watch out. The trail is sketchy. And you were like, da, 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 da.
Oh, it's square feet! So it's x plus 1 squared. Okay.
Either I need to take inches and make them feet, or I need to take feet and make them inches.
Okay.
But since this has already been given to us in square feet, it would make more sense to convert the inches into feet, because otherwise I gotta work backwards and figure out how many square inches is 12 square feet, which, reminder, that conversion factor is not 12, it's 144, because how many square inches in a square foot is 144. So this, we should really talk about as 1/2, which then when doubled is 1.
The equation's so much simpler.
Alright, try that now.
Well, square root 12.
Yeah, square root 12.
That does not seem as nice as square rooting the last one.
Yeah, no. Rectangle root 12. So it's 3 and 4. Wait, that's not how that works. Rectangle root. X equals the square root of 12 minus 1.
Yeah.
There we go.
Yeah. That's
Radical 12 minus 1. But not radical 12 minus 1. Radical 12 minus 1. Yeah.
Okay. Still feels relatively easy.
12. 2.46.
By 2.46, so square that number. Because we need the square.
The path is treacherous. Watch your step.
What? And we need to square the inside? Am I wrong?
No, we're just moving on.
Oh.
Do you notice anything?
Okay. Do you notice anything special about the horse? So we did 0. They were perfect square. You did 0, right? No. Yes.
Why are you talking about that?
I'm just answering the question. The board's asking me questions. It's 3. It's 1.
That's not.
Now here's the
It's
problem.
not possible. Wait, there's
Well-
no homework assignment.
Well, I mean,
Well-
if you use I, if you use
well-
the imaginary number.
Well-
then it's-
Well.
Well. Well.
Does A only have one answer?
Probably not.
Yeah.
No.
Yes.
No.
No.
Yes.
Okay. Just okay.
No. It's 3 or -1.
Negative 1. Oh.
Why?
Silly
It's
Connor.
not.
Why?
Because -2 or 2 can square to 4.
Because, yeah.
Oh, because it's a 4, it's
Yeah, I
not a
didn't answer
0.
So if we're
Still,
saying that some number squared equals 4, then what we're saying is that number, yeah, it could be 2.
But it can also be -2.
Yeah, I forgot that it wasn't 0. This was a math. This was a math.
So then we said
That one's clearly 1.
this one is 1 or...
Nothing else. It can just be 1.
Oh wait, why is that only 1? Whereas that has
Because
2...
it's a
Because it
0.
has to equal 0 squared.
Yeah, it's like those.
Because it's a
only-
parabola that has
Yeah,
only
it's
one
a
x-intercept.
So there's only one z that when squared makes 0.
So that other equation, if
I
you
gotta
want to
find
make
some
it a
better for this,
parabola,
yeah. Keep
I
moving.
think it actually would have to be x minus 1 squared minus 4 equals 0. And then that wouldn't be a perfect square. So that's why that one's weird. And then
So
C
wait.
is just not possible.
Well, technically, I don't think that's.
So is a quadratic equation just
no.
finding the y-intercept for a parabola?
No, not necessarily. Quadratics are an application used for a lot of different things. But wait, if I just play with this a little bit, x minus 1 squared plus 4,
No, it'd be minus. Well, it has,
That's impossible.
right? Like, can I do that? Does algebra let me do that?
yeah.
Okay.
Because x squared
And then you
Min-
can square root
minus
the
2x
whole thing.
plus 1 plus 5 equals 0. And then, x squared minus 2x equals -5.
X squared minus
And I think it's
That's not possible.
it's possible.
Does every parabola hit the x-axis?
No,
Yes. No,
they don't. Because
Okay.
they can be difficult and make our lives hard.
So this leads us to thinking about some of these were nice, some of these weren't. Right? When we had a perfect square on the left-hand side, and what? Well, that wasn't even. I mean, yes, that was the best, but what are we normally talking about when we say something is squared?
It's all about myself.
Yeah, but be broader. What about like if I give you inches squared, feet squared, miles squared?
You take the measurement and then you rotate it 90 degrees and the 2 segments.
Right, but what are we talking about? You're right, but what are we discussing?
Area.
Area. Can
I was right about
area
something.
in the world be negative?
No.
No.
Not unless you're in some weird alternate
I
dimension.
mean, when there are those signs that say like caution radioactive waste area, like I think that's potentially a negative area. But no, like it's a positive physical space. We have a place like that in Coshocton where it's like, hey, don't play in this field. You'll end up a mutant.
Mutant X-Men!
So
I'm gonna get superpowers.
So it brings us to these situations where, okay, so if they're saying a dimension take away 3 is going to be a positive area, then we know that dimension has to be greater than 3, and if we know this is actually going to work out specifically, there's a very specific number that when we take 3 away from it, squares to 12.
Yeah, but the square root of 12 is 1. Obnoxious number. So it's the square root.
By obnoxious number,
You mean irrational.
what you mean is irrational.
Yeah. It's
A
not very smart.
A non-perfect square is irrational. So most square roots are irrational. Pi is not, well, unless you squared pi and then take the square root of whatever, just square. But that'd be pretty difficult because it's irrational. Most of the time when we work with irrational numbers, we either leave it in radical form, normally my preference,
Radical.
or approximate decimal form. We know we cannot get exact. So, let's try these situations. You guys are pretty strong at doing this.
I don't like the ones that don't equal 0.
I think x equals 2 for the first. Wait, no, I don't. Never mind.
I'll work on F. I like F. F looks nice.
You guys want to split these?
S is 5 on it.
So you want F,
is
you want D
negative
and F?
I want D. I want D and F.
Alright. Connor claims D and F.
I got A and B.
No, I'll do A and B. I said
I
A.
already did A. A is 5.
Oh, well, I want.
Wow, Jake, already doing the work. That's just so toxic.
A is 5.
Wait, what?
Oh,
Okay,
no,
but
it's
it can
not.
also be
No,
a
it's not.
different.
Wait.
What?
Yes, it is.
Yeah,
Who's-
it can also be another number.
Alright, she gets A and B.
Yeah.
Because she was the first to say that there's another solution. You get C and E.
Oh,
What did you
Imagine
call?
not getting the basic
I
easy
already
equal to
did have
0.
one.
I know, that's also why I'm not letting you just default and take it. Jake.
No, Jake has to be B for his last name, because then it works better.
Alright, go ahead, take a moment. Don't try to rush yourself.
Well, it's impossible.
That's when you make mistakes.
So, I feel like I only have to do one.
No, you have to do 2.
C, X, and 1. 4, X is -9.
I want you to not allow something to be impossible. Solve it as far as you can.
Okay.
Because impossible,
Is it easy?
no, it's just not necessarily accurate. Like,
Accuracy.
I think what you're trying to say is it's not possible in the current, like,
Way to be
yeah, like the current realm that we're in, which is the real number world.
Yeah, you
Real
think about it.
number.
Imaginary numbers. Those are always fun.
That's something we haven't done yet.
I know.
Have we talked about imaginary numbers
No.
and how they're actually real?
No.
Imagine,
But I
no.
squared is
Imaginary
-1.
numbers aren't real, and neither are real numbers. They're all fake.
I have a video we'll watch before we get out of here.
Numbers aren't
That will blow your mind.
Is it going to say numbers aren't made up?
Oh, it's going to say imaginary numbers are real.
I'll believe that they're as real as normal numbers.
Imaginary is just a name. I'm not, like, imaginary is not actually being used in the right sense of the word. It does not mean imaginary. It's literally a word being used wrong.
Oh, like, the
I
word
got negative.
technical. No, not
Here's the issue.
the word that means figure.
When we look at square root of 49, when we square root both sides, what actually is the square root of 49?
Literally.
Or,
-7.
so the problem is when we start working this solution, we're actually going to have to think about the positive or negative options. Normally what I do, set up 2 problems. So I split to my alternative route and say, okay, so if it is positive, it solves how we want it to, or more so like how we're used to. So 2x equals 10, and then x equals 5, kind of like what Jake was arguing. But the problem is we can't then just take the opposite of that, which is the trapdoor that I wouldn't expect you guys to fall into, but I would expect younger, or not younger, I would expect older Math 2 students to potentially say, and the opposite. But it doesn't work like that. Because when we do the algebra...
The negative 3 is obnoxious like that.
Then you would get -4, and then x equals -2. Okay, that was interesting, but wow!
Now, mathematically, we would present both these solutions. But in a problem like the hot tub, you would not present to the client, or you could make this -2 feet.
Yeah.
You would probably not say that, right? Because then they might hire somebody else thinking that you have lost your mind.
Yeah, that's fair.
So this gets down to the nitty-gritty of mathematical solutions
In real life.
versus realistic applicable solutions. We would say both of these solutions, like in our notes, in our work, whatever, but then we would just go ahead and circle the x equals 5 and say that's our usable solution. We do have two solutions, just one in the realistic is usable. Now, if we're modeling something else, the negative might be usable.
Or what if it's just too positive?
Yeah, or that, right? So,
What if everyone's not always just a negative person?
right.
So like not middle school.
It's so not.
Interesting. I shouldn't be skipping the first steps here, but hey, we are.
What about first step skipping?
That's not a very.
I don't see the step that you skipped.
Square root both sides. I didn't write down the original.
Yeah, but it still shows the. Okay. Writing down the problem.
How would I write this?
You would do 5 and then minus the radical -2. Yeah, they would go about it. Well, plus, yeah.
If I want to make my life kind of easier, I can leave it in radical form, and I can write it as plus or minus, positive or negative, however you want to say it, because we do not know the exact square root of 2. We also don't know the exact square root of -2, for that matter.
Isn't it just
Jake,
like
you with
the
us?
square root of 2?
I feel like whatever you're doing, you might need to go get some nail trimmers or something. You've been going at that for... I have nail trimmers. Would that help? Do you like have a hangnail or something? I have nail trimmers. Would you like to borrow them? It doesn't seem fine. I'm offering assistance.
Yeah, just say yes.
Okay.
Okay.
Just say no, Jake.
So now, what do we want to do on both sides?
Divided by 7.
So I can write both solutions together
Wow. So
by saying x equals 5 plus or minus the square root of -2 over 7.
But I don't like that. I don't like it either.
Negative
The way he's doing
minus
that
the
makes it
square
seem like
root
there's a problem.
b squared minus 4ac.
Wait, is that what this is?
Are you
This
singing
is
the
that
quadratic
obnoxious,
equation song that you
Soggy.
Jake had to bring up a few classes ago?
A few classes ago,
A
like
few
3
months
months
ago, and then you started like saying you're gonna regret this, and then you're gonna say, well, we're gonna see it again, and now we're seeing it again, probably.
I don't even remember that video, honestly.
I do. He was on a
You
mountain.
might want to stop recording. I think it's legal.
You can tell that it's dubbed, right? Or like that he has layered over his
Yeah.
singing over top of the video. But still, he lays down that rap like it's nothing, right? He just flows through all of that math. That is
That's
like,
called a nerd.
that's like mega discovery day right there.
What, singing
I mean, come on, he
math?
was on a mountain with like a drone shooting his footage probably. So here,
Every day for college.
if we square root both sides, we would get, ooh crap, I'm moving too far ahead. Square root both sides. So we're a few steps down that process we just saw, right? Because we're already to the square root both sides and then subtract and then we're isolated. So radical 20. When we write it, we want to go ahead and write plus or minus, positive or negative, to make sure we don't forget. And then actually the nicer way to write this would be -4 plus or minus radical 20, just so we don't get confused about what is in the radical. But actually, there's still a nicer way to write this, because radical 20 isn't terrible. Why isn't radical 20 terrible?
Because you can multiply by 4 and 5, so then you get 2 radical 5.
We can factor
Yeah.
our non-perfect square.
Ooh.
Yeah.
So we factor it under the square root. What this actually does, and we don't have to write it, we just know it, it's actually able to split the square root.
It is?
Stop.
Doesn't work with addition or subtraction. Does work with multiplication, division. Because remember, hey, come back. Because this is what I used to make mistakes on all the time.
Where are they
Square
multiplied together or
roots.
added together?
Square roots and squaring is just multiplying and dividing, right? It's repetitive multiplication and division. So this stays multiplication.
Okay.
We're just essentially using what property? It's one of the properties saying that I can just write things differently. I think it is, like, I'm trying to make sure that it is commutative property. Because we're not actually changing the order, we're just changing how we write stuff. So this turns into square root of 4 times square root of 5. Square root of 4, or square root of 5, not nice. Square root of 4 is -4 plus or minus 2 radical 5 would be the factored form. Now, we cannot add or subtract the 2 with the -4 because it's stuck with multiplication.
But the 4 can't be.
The 4, it's
It's not.
just there. It's -4.
It just kind of like sitting there by itself.
Oh, no.
Yeah.
So,
Plus or minus.
Because it can be a positive or a negative.
sorry, what?
Oh, yeah.
Because remember, if you square a negative, it becomes a positive.
Yeah.
If you square a positive, it becomes a positive.
I get it now.
I just brought Jake something.
Connor, what'd you find out about D?
The answer is 0.5.
Just 0.5?
Yeah.
Okay, so when it's equal to 0, I'm starting to hunch that when it's equal to 0, there's only one solution. Okay.
Because you're taking the y.
Okay.
You're taking the
So-
y-intercept of the parabola.
Jake, I accidentally erased the bottom of your J, but what'd you find out about E?
Yeah, t.
It's impossible, but I factored it down to x equals -2 plus or minus the square root of -10.
So it's not that it's impossible.
Oh.
It is not that it's impossible. Guys, what it is that we lack the ability to see the answer as it is.
What the?
Seriously. So take that statement, put it in your head for a second. We lack the ability to see those
Is
solutions.
that like how most of us can't see some colors?